Hello and welcome to Advanced Algebra. This is the first lecture of a series of lectures in which we're going to learn how to combine function. Let's begin. So what do we mean when we say combine functions? So we're going to be given two functions. Let's call the first one f and the second one g. And with these two functions, we're going to create other functions. Okay, so this is also called algebra of function. We're going to learn how to do some algebra with these two functions. Okay, so let's start with the first function we're going to define. We're going to add the function f and g. We're going to define this function. We're also going to subtract the function f and g, and then, as you can guess, we're gonna multiply the function f and g, and finally we will divide the function f and g. These are new functions, right? We don't know what they are yet. We have to define them. How do you define a function? By telling what it does on an input. That's how you define a function. I'm gonna tell you what it does if I put an input in the function. So how do you define the first one? It's very simple. By the way, I use this symbol to mean definition. It's an inequality, but it's a defining inequality. Okay, I'm assigning a definition to this expression right here. At this point, I have no idea what this expression means until I define it. So how do we define the sum of two functions? This is called the function sum, or the sum function. It's simple. You just add the output of each function, right? So the output of a sum is the sum of the output. The output of a difference, well, it is a difference of output, right? Again, very, very simple. The output of a product is the product of output. And finally, the output of a ratio is, of a division, is the ratio of output. So you can write it like this, or you can also, this last one sometimes is written as f over g, okay, of x, and that by definition is f of x over g of x. Okay, so the last two means the same thing. Actually, there is a fifth one I need to define. It is if you take k in R. Okay, so k is any real number, any real numbers. How do you define k times a function? So this is a real number, right? This is a real number, but this is not a real number. This is a function. So I have no idea what it means to multiply a function by a real number until I define it. So let me tell you what it does to an input. So this, by definition, is very simple. It is k times the output of the function. That's it. That's all. Let's go over some examples. So here's the first example. I'm given two functions right here, and I want to define these three functions. Well, let's start with 3g minus f. So let's express what it does to an input. So by definition, 3g minus s means 3g applied to x minus f applied to x. I understand that. I'm not sure about this. We need to go one step further. So what is 3g applied to x? Well, this is 3 times g of x minus f of x. And at this point, everything is clear. I'm going to do 3 times. What is g of x? It's x minus 1 minus, and what is f of x? It is 2x squared minus x minus 1. All right? So it is 3x minus 3, right? You got to distribute here. And then minus 2x squared plus x plus 1. Be careful, you have a negative sign in front of the parenthesis. And so finally, this function is negative 2x squared done with this. 3x plus 4x minus 2 plus 1 minus 3 plus 1 minus 2. That's it. This is 3g minus f. Let's continue. The next function I want to find the expression of is f times 2g. So f times 2g applied to x is f of x times 2g of x. So again, I need to go further with this one. So it is f of x times, what is 2g of x? It is 2 times g of x. So now it's pretty simple. Let's grab the expression for f and for g. So f is 2x squared minus x minus 1. So it is 2x squared minus x minus 1 times 2 times, and g of x is x minus 1. X minus 1. Okay, so please be careful right here. Don't make a mistake. I'm going to first give the 2 to the last factor right there. So I have 2x squared minus x minus 1 times 2x minus 2. And now we need to FOIL. So let me create a little bit more space here. Here we go. Let's push down everything. And a little bit more. Here we go. All right. So how do we do that? Well, we'll need to distribute, right? So 2x squared times 2x, 2x squared times 2, then negative x times 2x, negative x times 2, and finally we'll have negative 1 times 2x and negative 1 times negative 2. Okay? So what do we have? I'm going to start right here. 2x squared times 2x, that's 4x cubed, minus 2x squared times negative 2, negative 4x squared, then minus x times 2x minus 2x squared, minus x times negative 2 is plus 2x, and then minus 2x, negative 1 times 2x minus 2x, and finally plus 2. So these two will cancel. I gotta combine these two, and finally I have 4x cubed minus 6x squared plus 2. Make sure you can do that, okay? Don't just look at me, try to do it too. All right, next and finally last expression, what is it? It is f over g. So basically what you have to do, you take this one and you divide it by this one. 2x squared minus x minus 1 divided by x minus 1. So f over g at x is by definition f of x divided by g of x. And so it is 2x squared minus x minus 1 divided by x minus 1. Please make sure you just don't do this kind of simplification. That makes no sense, right? Because to simplify a fraction, you have to divide by the common factor. And x minus 1 is not a factor of the top right here. Actually, what are the factors of the numerator? Well, let's try to find them. Let me try to factor the numerator. Maybe I will, maybe I won't. I don't know if it's factorable. So how do you get your 1? This is a 1 and a 1. And here you want minus 1, right? So 2x times negative 1 is negative 2x. Yep, I can factor it. Okay, that's it. And so divided by x minus 1. Now, I do see that I do have some common factor right here. These are two factors, and that's a factor of the bottom. I can simplify, and I find 2x plus 1. Okay, so sometimes you will be able to simplify like that, and sometimes you won't be able to simplify like that. All right? In this case, I did. Okay, please do the second example on your own. Here's f of x and here's g of x. Find the expression of these three functions, and you will have to answer on the video the expression for each. Just enter x, so for example, if you have some x squared on your computer, just enter 3x and put the caret mark right here to specify squared, right? That's it. I will understand what you mean. But make sure you enter the 3 expression. Let's continue with another example. All right, example number 3. So this time I have these two functions, and I want to find f over g and g over f. Simplify it as much as possible, if it is possible, right? So let's start with f over g at x. What is this? By definition, it is f of x over g of x. Please always tell me what it is equal to. Don't write directly the ratio of the expression. You're showing me that you know the definition, okay? So it is 10x squared minus 13x minus 3 divided by 2x minus 3. Okay, can we simplify it or can we not? It depends. Do you have any common factors right here? Well, I don't know. Let's see. Let's try to factor the numerator to see if we have some common factor with the denominator, right? Well, the denominator only has one factor, and that's 2x minus 3. So 10x, how can we make a 10x squared? We can have 1x and a 10x, or we can have a 2 and a 5. I always start with a 2 and a 5, okay? Maybe I'm wrong, I don't know, but I always start with a 2 and a 5. Especially given that this is not a huge number, right? If you had a 1 and a 10, you would expect maybe a bigger number here. I am not sure. Okay, let's see. 2 and a 5, and here I have a 3, right? How do you make a 3? Well, it can be a 1 and a 3, or it can be a 3 and a 1. Which one might it be? Okay, let's look at this one. You have a 15 right here, 15, and you have a 2 right here, right? We can make a 13 with a 15 and a 2. So how do you make a negative 13? You need a negative 15 plus 2, right? This is plus 2x minus 15. Does everything work fine? I got my 10x squared. I got my negative 3 times 1 is negative 3. And I got my negative 15 plus 2, negative 13. Yes, that's it. That's my factorization, okay? So we've done that previously. I hope it's you remember a little bit of it. And oh, look at that. Actually, I can simplify a common factor. I do have a common factor here. And so it is 5x plus 1. Well, guess what? Of course, if you do g over f, then you will find the other one. This is g of x over f of x, right? And so it's going to be 1 over 5x plus 1, of course. Okay, the procedure will be the same and the simplification will be the same, except that this would be at the denominator now. Okay, let's move on to the next example. Please complete number 4 on your own. Let me go to the final example. Okay, so this time the functions are given with a table. So be careful right here what you're reading, guys, okay? These are my input. This is a column of inputs. These are the outputs of f, okay? While these are the outputs of g. So for example, it means that g of negative 1, so negative 1 is the input, and for g the output is negative 4. It also means, for example, that what is f of 3? So 3 is the input, and the output of f is negative 1. That's what it means, okay? So let's answer these questions now. Let me erase all of that right here. Okay, so let's answer these questions. You will see this is very easy. What is f plus g at 1? Well, by definition, it is f at 1 plus g at 1. So f at 1 is 3, and g at 1 is negative 3. 3 plus negative 3, that is 0. You see, I told you, very simple. Let me do number 6. F times g at negative 1. By definition, it is f at negative 1 times g at negative 1, right? So what is f at negative 1? 0. Well, hey, I know what the product is going to be, right? It's going to be 0. Doesn't matter what g at negative 1 is. But g at negative 1 is negative 4. And so, as I said, it is 0. Okay? Again, very, very simple. F minus g at 3. This is f at 3 minus g at 3. And so it is. What is f at 3? F at 3 is negative 1 minus g at 3 is 2. So it is negative 3. So please, I'm going to ask you to finish the last 3 questions and write your answer in the video. Thank you for watching.